And thanks everyone for coming through to my talk called Contracts for Hire, but really it's about contract testing. So what's contract testing? But more importantly, I guess why is contract testing? And it really all started with this idea or this notion of we have monolithic software, monolithic architectures. That's how we used to build software and build our systems into one big beast of a server. But the reality is, what we realized is the bigger you make a system, the more difficult it is to maintain it, the more difficult it is to test it. And we went from creating applications that were quite useful and powerful, but they needed months and months and months worth of software iterations to keep up to date. So you were deploying once a quarter, or at best once a month, because they were just too big and they required too much testing. So the idea was born of, let's create a microservice. We've realized big is difficult, big is slow. So why don't we take these big applications, and instead of making one big one or several big ones, why don't we make lots of smaller ones instead? Why? Because small software means that there's a little bit of code for each little bit of iteration to maintain. It's a lot easier to test because you know the boundaries of your microservice and being able to get it out there and deploy it effectively. And what it will do is speed us up. And it worked. The reality is microservices have changed the software world probably bigger than most other forms of architecture have. And it really led us, particularly with the cloud and being able to adopt to something that can deploy in a small space in the cloud, have really led us to the next forefront of software architectures. But there's a problem. It doesn't scale well. It sounds great in principle that small is better, but the problem is you end up with a lot of small. And so while you might think, oh, this particular microservice is quick and we're able to, as a team, go and deploy fast, the reality is we now get to testing, but there's not just one microservice we're working with. There's a whole bunch. There's 10, 20, 30, 100. In my organization, we have over 1,000 microservices. From APIs to micro front ends, it becomes difficult to work with. And now we've created this problem where, yes, we're moving fast, but we still have to slow down and test. Why? Because there's too much interaction, too much dependencies to be able to work with. And that's where the idea of contract testing is born. But before I continue on, a little bit about myself. You obviously did hear from my bio. I don't take myself too seriously. So feel free to, to come speak to me afterwards and interact. I do work for a company called Old Mutual, which is quite a large financial service organization. And I also have a board game company on the side, Risky Games, where I love to create and write board games. And I have my own website where I blog and where you're welcome to come find things. But I also have several books out around quality and the notion of software architectures. So if you're interested in any of those topics, please feel free to get a copy of those books. They are available on most online retailers. And if you're wondering where my accent comes from, I'm from Cape Town, South Africa, and this is just a few pictures of the city that I live in. And believe it or not, yes, that is the city that I live in. That is not going out remotely. That is something that can be found within our city limits. So love staying in Cape Town, so please come visit if you've never been. But let's get back to the idea of contract testing. We've explored why contract testing exists. So what is it? Essentially, contract testing is this idea of, instead of trying to test all of our services together and creating these big integration cycles where we've now got to take our deployments of these microservices and now test them with a variety of other teams to make sure we haven't broken anything, let's rather just test the limits. We know that we need to interface with another system. We don't actually need to know what that system does. And I guess more importantly, we don't need to know that that system has been well tested or not. All we need to know is what information does that system need from us, and how do we expect it to respond to that information? And that's really the principle of contract testing. It's trying to break down the cycle that you see at the top there and move it into that thing where instead of trying to test all 4 components together in this example, we're just testing each component with the necessary thing that has just been changed. So if I am working with component D, I really only need to test component D with a contract of component B. I don't need to worry about A and C or perhaps even B itself. I just need to know what are my boundaries and does it hit. And that's really the idea of what we're trying to solve here. Is we're testing just that integration limit, but not going into too much detail to make sure that everything of it works. But now you might say, so what's the difference? How is that any different to integration testing? The only thing is it sounds like you're doing integration testing, but you're doing it in a bit of a half-mannered way. You're not actually solving the problem because you're simply just testing a boundary and not testing an actual integration, which is true. But then why do we do it? Well, essentially, we're doing it because it's faster. Particularly if we think of the cloud notion, we don't want to go up and then be able to deploy and now have another dependency that we need to work on. And now when we're deploying something, particularly in a pipeline, now we've got to go and deploy 2 applications and run both applications. We want to be able to just deploy our application and be able to ensure that we know that the boundaries of our application work completely well. And just by doing that, we can deploy independently of knowing what's going on with that system. That system can be on another few changes. That system can be on another version. We don't need to know that version. We just need to know what are the limits that we need to hit. And I'll go into an example of that later when I open up code. But essentially what I want to look at is what's the minimum boundaries that I need. To think about it this way, think about it as about software compatibility. What do I need to be compatible with this module? This module can be 5 versions ahead of me. That's okay. I don't need to know its new features. I just need to know, is it compatible with these features? And if so, that's okay. So each team can start to iterate more independently and and then operate more, help us to be able to then deploy here and deploy here, which helps to scale our software applications better and prevent that dependency problem that we have. It's also a lot faster. Because we're not deploying actual applications every single time we're testing, and now we're spinning up and trying to run automated tests to be able to run in a pipeline across multiple different environments, we can test very quickly. The speed of a unit test is the same speed of a contract test. So now we're able to not just get through unit tests, we're able to get through significantly more tests with all of our integrations at the same time, significantly quicker. So by the time our CI/CD pipelines are running and have run, we've covered a lot more ground, and we can have a lot more confidence in the software that we're producing. So I guess in summary, what are the problems that we're trying to solve? And I'm not saying summary of my talk, I'm just saying summary of that particular point. We're trying to look at what's going to break. We know that with microservices, one of the biggest problems is those integration breakages. How do I know that when I'm deploying something else is not going to fail? That's why we go to these endless end-to-end cycles with our microservice systems, trying to make sure that nothing else is broken. But by leveraging contract testing, we'll be able to very quickly identify something doesn't match the contract I'm expecting, something changed in those minimum requirements I'm looking for. I'll be able to quickly identify something's not working, and it solves a lot of those problems. I'll get into a little bit more of the how. It prevents the fragility that we have of endless end-to-end cycles, of a lot of integration problems that we're trying to solve. It's very fast when it comes to CI/CD, which is one of the biggest challenges of test automation, is how do you get as much coverage as possible in the shortest space of time. It solves that problem for us. It allows us to be able to achieve a lot very quickly. It allows us to isolate, as I've said, and really the whole purpose of this is to restore confidence in our ability to scale. Because microservices were great, but we've lost a lot of that connection because we're now trying to deal with too many of them. And by enforcing proper contract testing, we'll be able to solve that problem because we can now deploy independently, we can work at scale, and we can get that confidence back in our, within our organizations because we're able to deal with it. And it also solves dependency hell. You don't have to worry about your dependencies anymore because you can operate independently of them, as I've said. So those are the problems that we're trying to solve with contract testing. So where does it fit in the traditional testing paradigm? And I think this slide's important because it doesn't just show where it fits within the overall sort of testing pyramid, paradigm that we're used to working with. But it also shows one of the biggest weaknesses that people have around contract testing, which is the idea of contract testing is there to replace our integration testing, and contract testing is there to replace our end-to-end testing. It's actually not. Now you might be thinking, but Craig, you've just started off talking about how it's going to solve all of our problems, but now you're saying we must still do them. I think to a degree, yes, you might not it's not going to solve all of your problems. I'm not saying that you should never do integration testing, and I'm not saying you should ever do end-to-end testing, but you don't need to be as reliant on it as you used to. It fits firmly within the middle of where you're trying to get to, where you have your unit and component tests operating within your CI/CD pipelines, which is typically your CI area. But now when you're getting to CD perspective, it gives you more reliability in that to get you better coverage. So when you do need to do integration testing, when you do need to do end-to-end testing, you don't need to spend as much time doing it, and you can do it a lot more effectively. Think of it like this way. Again, the whole notion of speeding up. It allows us to be able to operate faster. We can scale and scale and scale, and if we want to add contract tests, multiple contract tests, multiple new APIs into the system, we're not drastically changing our speed of testing. Whereas if we were to take the normal end-to-end approach, for every new API that you add into the mix and then trying to end-to-end test that within your bigger system, you're massively slowing down. And it goes to that point with a curve where just one API can all of a sudden cause 1,000 extra tests and slow you down by a couple of weeks, hours, whatever it is that you're working with. Whereas with contract testing, again, it's very scalable. You can add a new contract, add a new contract, add a new contract. It's not going to really slow you down because each new contract doesn't drastically require you to retest the other thing with you. And again, you might be thinking this still doesn't make any sense. That's okay, we're going to get to that. So again, what are those benefits that we're trying to achieve? So faster execution with easier maintenance. We want to be able to execute our code fast, we want to be able to test our code fast and be able to maintain more frequently. So we don't want to deploy our code once a month, once a week. We want to be able to deploy every single day. And make sure that while we're deploying every single day, we're not going to cause other dependencies to fall over. It helps solve that barrier. It allows us to debug a lot faster because we're still working in the microservices mindset where these things are smaller. It doesn't mean we have to now worry about our dependencies where we're now trying to problem solve because we're always focusing on our own thing. So when our tests are failing, they're always your tests. They're always your code that's failing because we're not actually executing someone else's code. So you can debug a lot faster. It makes your software a lot more reusability. It obviously helps us scale, as I said before. And it allows us to catch bugs earlier, which is what we want. As software testers, this is the goal of what we want to try to do. It's not to find defects, it's to find them as soon as possible to save the company the most money. So Craig, all of this is great. You have sold us on contract testing. It is the future of microservices and solving the microservice problem. I still don't know what it is. Great, now let's get into what it actually is and how this works. So what is a contract test? And I think pretty much like when we want to sign a contract with anything, just like with any sort of legal system, and I don't know if any of you have ever bought a house, but when you buy a house, the bank normally has about 50 pages worth of things that they need you to sign. All these contracts and rules that you need to be able to meet in order for the sale to go through. Well, that's essentially the same thing of what we're trying to achieve. So what we're looking for here is, again, we have two services. And in the notion of contract testing world, you have a consumer and a provider. So that provider is this service. Here's a microservice that does something. And my consumer is another microservice that calls this particular information for something it needs. And both can be consumers and providers of each other. You don't need to just have one or the other. You can both be consumers of and providers of each other. But now what we're doing is we're saying, I don't want to test that actual system. I don't need to test consumer system A and system B every single time I'm deploying. That's wasteful, especially as we've spoken about, as you get to scale, it becomes problematic. So what I'm going to do is instead, I'm going to create a mock of my provider and then a simulation of my consumer. So when I'm updating my consumer and writing code for that, as a developer, I'm at the same point in time updating my contract on that side, and then I'm doing the same. So you follow the green and the blue blocks. So every single time I'm updating my code, as a developer, I'm forced to update that mock. And those mocks are built on a contract of this is what's expected for me to behave. So if I'm a consumer and I'm saying I want to have these 3 things that are important to me and I want this information, that becomes part of my contract. Now, as a provider, I can add details to those to that contract and say, but I also offer this service, this service, this service. That might not be important to me. I just need these 3 things, we're still good to go. But if I still all of a sudden change something and say, well, hang on, I now need this information extra in order to produce this output, it would fail. I don't need to run that second service. Have service A, service B. I can fail it just by seeing that the contract has changed. So I deploy C, contract has changed, rollback, or fail. I'm not actually going in and needing to run both applications at the same time. So to put it a little bit more in a flow here, I am a consumer, I generate a contract. So this is what I need to be able to operate and be able to perform my function. I publish that contract. A provider goes and then picks up that contract and then is basically going and say, okay, well, I have this contract. Can I meet it or not? And if in my current code base I can meet it, I'm going to say, yes, you passed. Or hang on, there's something that doesn't quite align with me, you failed. And that contract isn't running code. It is simply just something that it can read to be able to understand what is happening. That is the notion of what contract testing is. What do I need? Firstly, I need a contract definition. I need to have and understand what those contracts are. What's that defined minimum that we're looking for? What are those consumer tests that I need? So I know that I have a contract. I need to have, with each sort of criteria, some tests that need to meet to ensure that I'm happy that it's meeting that particular contract. And I do that on both the consumer and the provider side. And it needs to be mocking. Because again, I'm not going to be working with an actual system here. We don't want to deploy multiple systems. We want to just deploy our system and be able to ensure that it's going to work effectively. So we mock and stub every single other service. So if you've got 100 microservices, that means you're going to have 100 contracts in place between those interaction models. But by having that, I can deploy without needing to worry about them. And then obviously a lot of verification that needs to get done. So I'm going to actually break out of this now, and I am going to instead load up, and just to give you an example of what that looks like, I'm going to load up and just show you a piece of code. So you can put this into multiple different files and stuff, but I just want to briefly show you, so I've just put it all into one sort of spec file to be able to show you what it is. But this could be something where, and I've got a consumer spec here, where this is what I'm saying. So I'm going to post a message. This is the body that I'm expecting back. I'm expecting a first name of, and I've put this here, so that first body is first name. I'm looking for something that gives me that information. This API call is simply just looking for, I want a name, a last name, and the person's age. That's all I'm looking for, and that ID of 3 is just that it needs to have, I just need those 3 fields. There can be 5 or 6 fields in there. My code is sitting here, so I can have my consumer code, I have my provider code, so I have both APIs running in here. I don't need to worry about them. I can just come into this here and be able to see. And this is just simply me describing how my test wants, a little bit of my framework to do, and then I can write some tests in terms of making sure, does this work properly, does this not work properly, and then putting in stuff here. Now, I can have this. This is my get expected body. I want to say, now I want to send these messages. I can come here as a provider. Let's come back here and start to change. And I can add a number, whether it be a phone number or something, and put it in here and say, this is something else that I want to be able to create. So I want to post that and I need this. Now, I've all of a sudden started to change the contract. I've come in and said to my contract, I actually haven't changed the code at all. So as a developer, if I'm starting to now change that, I will now go to my mock and change it here. And just because I have changed that I'm needing something else because of my post, it's not going to be able to, if I were to now send this test in, it's going to come back and say, more information needed. I won't be able to return something. And that's how, just by adding a line to your contract, I can keep it in sync. I'm not trying to replicate the entire system. I don't need to run the whole thing. I'm just needing to showcase that this is the bare minimum that I need. So again, it's quite a simple, this is a very simple example. If you ever want to, you can speak to me. I can point you to my GitHub repo where I've got a lot more complicated examples around how this works. But what's really important is just to understand that it's quite simple. I'm just saying these are the things that I'm expecting. I'm expecting some basic stuff here, and then I want to add something to my expected body to say that I want to add another piece of information to this. So as a team, I'm going in and I'm service B, and I've added a new part of my API where we now start working numbers, and I start to add that in. Now the other thing is I'm adding this in to say that's the expected part of my body. But if I add it in here, and then I start to type in that number here, it's not going to, and I'm not going to run it, but it's not going to fail the system. Why? Because my expected is only looking for those three things. I can add a lot more here and send it a lot more information. It only needs those three things to run, and it's only going to give me that information on those three things. So again, it depends on what's the bare minimum within the contract. That's what it's looking for. And that's really the idea of what you're trying to achieve through contract testing, is those simple things. So what do I need to be really good at contract testing? What do we need to be successful? We understand that we need contracts, and we need contracts to be maintained. So it's very important to know your contract rules. That means that up front, before you even start developing, your developers should have an understanding of what the contract is that they're trying to hit. Think of it as test-driven development. It kind of enforces that principle. Before I even write my unit tests, I'm already needing to be aware of what contract do I need to adhere to in order for me to operate with my dependency. It causes us to ask the questions up front. And the nice thing is that code already exists. I can go and have a look at their contract. I don't need to run their application. Their contract's published, and I can go, okay, that's their contract. I know what that API format needs to look like. I'm going to write some tests against that. So every single time they make a change to their contract, my test is going to look at their contract and go, something works, something doesn't. It forces us to know our dependencies. We've got to be able to know our dependencies well to make this work. Again, if you're working on one system that integrates with another system, you might think this seems like a waste of time. But if you have 50 different dependencies that you need to work with, it becomes critical. So it helps you to, if you know your dependencies. It requires a lot of early analysis and involvement with architecture. You can't make this work if your architects aren't deeply involved with how you're building your software. You need to have very well unit-tested APIs. We've spoken a lot about the contracts. Again, we don't know whether that system actually works or not. And if you have an API in your system that's continuously buggy because it's not tested right, it kind of feels like everything's falling apart, which is not the case. What you want to be able to achieve is a lot of success with that. So you need very well unit-tested APIs. You need to have them integrated into CI/CD pipelines, but you also mustn't ignore those other forms of testing. It's very important that you don't ignore your functional testing, that you don't ignore your end-to-end testing, that you don't ignore that integration testing, your performance testing. All of that's still important. This just adds another layer to make your CI/CD pipelines a lot more trustworthy. And as you build up confidence in it, it allows you to eventually start relying on those other forms of testing a lot less. And lastly, just some tools. If you ever want to get into it, these are some tools that you can use that will help you. You don't have to go and create contracts from scratch. You don't have to spend a lot of time doing it. Tools can help you do this quite quickly. They can define your contracts. So as your code changes, the contract automatically changes, and they manage the contracts on your behalf. Thank you. Craig.
Thank you, Craig.
Thank you. Pleasure.
Listen, let's see if we have any questions for you. Oh my goodness, we have some questions for you. Okay, what are the difficulties of introducing contract testing?
I think some of the difficulties is that initial slowdown. It requires a bit of extra effort. I'm not just rushing in and developing, kind of like test-driven development. We need a little bit more thought into this. And I'll give you a brief sort of story around it. But I worked for an organization where we were trying to help a client solve a problem. And we told them what we're going to do first is go and build the mocks, build all the contracts in place before we even produce a single line of code. In the first month, we produced nothing but contracts and pipelines. They weren't too happy, but within 6 months, we were the fastest running team in the entire organization because we could operate so fast. So it's that initial time. It's trying to convince the company that I'm going to spend time building out these contracts, understanding these contracts, and building out tests for these contracts before I actually start sometimes doing work or putting some analysis in place. So you start off slow, but you move very fast. Because once your contracts are there and you've put in the mechanism to keep the contracts updated with the tools, you move a lot quicker.
Okay. Contract testing looks just like integration testing. How are they different from each other?
So with an integration test, you're actually taking 2 systems or 3 systems, and you're actually running actual tests against that live system. Here, we're not trying to test against the live system. We're just testing about how the live system should integrate. So I'm not actually trying to run or load that system. I'm just working against the contract and just saying, based on the contract, which is based on your last deployment, this is what I'm needed and the information I'm needed. So we're not actually doing any testing against that other system. We're assuming the other system is working based on the contract.
Okay. What can we do if consumer side writes contract test, but provider side doesn't? Contract tests are usable in a one-way implementation?
Yeah, that's a problem. In order for it to work, both sides need to honor the contract. If someone's not doing it, then the contract's automatically broken. So both sides need to honor some form of contract. So if you have a contract in place, both sides need to be able to read it and adhere to it. If one side is not willing to produce its side of the bargain, that doesn't help. So you need to approach this as an organization strategically. You can't just have one team going to contract testing and another team which is dependent on it not do contract testing. Both teams need to make an agreement.
In shift-left approach, when to introduce contract tests if services are owned by different teams and version compatibility can't always be guaranteed?
So it will be owned by different teams in a lot of times, and it doesn't have to even be teams within your own company, but as long as there's sort of strict rules in terms of how they work, it can happen. So you need to just, every time a piece of code is produced, you should be able to, if you're using the right tools, it'll automatically go and post something to the contract to say, this thing is now currently on version 2.17, and it's got these fields in it. So I know every single time my API is updated, this is the latest version of it, I can go and check and say, well, is that important to me or not? Sometimes it's not important to me. I don't care that they've added 5 extra fields. I just need these 4. I need them running at this version, and I can do it. You do need to have some sort of protocols in place. This is where your tools come in hand because it makes it easier. But there is also some quality gates that you need to introduce as an organization. If you want to govern this properly, you need to have rules to say every API needs to have a contract, and these are the rules to that contract. And then you can kind of search to say, well, before you deploy, have a look at the contract. Has it been updated? And then what you'll often do is, as you get good at this, you're trying to deploy, and your build will fail because there's 5 other teams that are not going to work with you now because you've broken the contract.
Okay.
Yeah.
If we want to introduce contract testing in hindsight, meaning already have 100% operational services, what would you prioritize and get started with?
And we ran into this problem because when I joined the organization, they already had 1,000 APIs. So this is something we had to do in post. And I will say this, AI is your friend. So going in and writing a lot of the stuff seems complicated, but we could very easily go in and ask AI to say, can you quickly build a contract based on this code base? Now we need to make sure firstly that code base worked, but that it could go and generate a lot of that for us to be able to kind of help. And then it also, what's often useful is looking at dependency mapping. You don't need to have necessarily all 100 microservices on this, but you know these are your 10 most dependent microservices. Maybe start with those. And then you start to break the problem down from there. So if you know that there are really critical, APIs within your organization, you just focus on those, and then only those APIs that interact with need to do it. You might have a lot of APIs in your organization that are really not dependent on anyone. It doesn't really count then. So you just use those APIs that are really dependent on each other and focus on them.
Okay, we have time for one more question. I'm going to choose one, the last one. Who writes the contracts? Do they have a format? Is the contract the same as test ID for FE, so extra work is needed for the BE devs?
So typically, yes. So typically, the dev should be writing the contract, but there should be some sort of functional specification produced. If it's new code, or something new, the contract should be defined beforehand. If it's existing code, you should know it, and if you're making modifications to it, there should be a clear indication that we're making these changes and it's going to have an impact on our contract, and then the dev's responsible for ensuring that that happens. But really what you want is an entire team around it. So the dev creates the contract, but the QE or the tester will write the tests against the contract. So they're operating independently, but for the same cause. And so if the dev forgets to update the contract test will still fail, even if the code's actually working, because the contract's been violated. So you kind of need to tackle it as a full team.
The last 4 questions, you can find Craig here in the conference and ask him your questions personally.
Please do.
So thank you very much.
Thank you so much. Cool.
Great presentation.
Thanks, everyone.
Hope you enjoyed it.
I did. Thank you.